Welcome. In today's video I'm going to work on the crank and the plunger. And the plunger is basically the part of the crank that's got a pin that's going to register in the indexing plate, and that pin you can pull out and rotate and leave it, and it will automatically self-locate into the hole. Now I've got this piece of scrap stock that I found in a bin. This diameter here is around 16 millimeters and this side is 13.5. Now this is perfect to make the plunger. Now I've got another piece of aluminium stock that will form the handle around in the top of the plunger. But this section here will form the body, and this section here will be the actual plunger that goes into the body with a pin in the front. So what I'm going to do now is I'm going to clamp it on the cleaned up area, and then cleaning up the space in the outside for the body. Now I need to take it down to 12 millimeters because I want to have a 12 by 1.75 millimeter thread in the crank itself, in which this the body will screw into. And then once I've completed the body, the holes and everything, all the features on this side, I'll turn it around and then work on this side, do the plunger's features, and then part it off here on the side. So it will just assist me with my work holding. So I hope you enjoy. It's at 15.04. It's close enough. Now, what I've done is I've cleaned up the OD. Now I need to cut in a recess for M12 thread. I'm going to single point it a bit because experience has dictated that my floating die holder and the machine doesn't have enough grip to run a M12 a die on this machine, so I'm gonna single point it close to final size and then just run the tab over it to clean up the threads, remove all the burrs and so on. Touch off on the side here, so I'm going to move over 25 millimeters, and then I'm going to cut in a thread relief at the back. I apologize for the noise in the background. So one of my neighbors is busy cleaning yard with a leaf blower. So yeah, it's a bit noisy. So I'm going to cut the thread relief 2 millimeters deep because the thread or the minor diameter should be around between 10 and 9.6 millimeters. So I'm going to opt for cutting it down to 10 millimeters. Okay, remember that I've made the previous ones 9.8 millimeters. That was 1.1 in a radius. Okay, so now I'm going to take my threading tool and make chamfers in the front and the back, and then start threading after I've changed the change gears. Okay, before you start threading, it's a good practice just to make sure that your threading tool is square to your chuck. For that I use a 1-3 block. Because it may look square by eye, but in reality it will be out. Okay, there it's 1-3 block. It's no longer square. Right, now I can do the change gears and then bring it back. Okay, now I've barely started and I've already made a mistake. I've disengaged my lead screw, and on a 1.75 millimeter thread you cannot engage lead, use the TDI, because on a TDI there's no 1.75 indicated, and that has been the cause of my problems on my previous attempts. Now, every time you engage on, say for argument's sake, you choose number 1 on a TDI, no matter how many times you cut it, you cut your threads away on that very same position, because the lead screw and the TDI's gear ratios doesn't cater for the 1.75 mil thread, so you have to keep your lead screw engaged at all times. So yeah, now I've already made my first mistake, so now I need to pick up on these threads again. Now for that I'm going to use the compound. Just bring it in closer. Just move the tip of the tool until it sits inside the root. So you'll notice that I'm not using a 30-degree angle cutting these threads, exactly for this reason. In case you make a mistake, it's easier to pick up on the threads than it is to have the compound at 30 degrees. Now this is mild steel and it's going to leave a terrible finish. It loves to make or create burrs. So that's why I run that tap over or the dye over the finished threads. As soon as the nut starts going over the thread, then I know it's good enough to clean up with the dye. Alright, let me back it up. Now, another thing that's also hair-raising for me is the fact that I need to back out the table every time I get to this point to my thread relief, and I'm very slow with this. So if you see me crash the tool, then you'll know it's me being too slow. And another problem as well is if you crash the tool, you have to reset it and acquire your position of your tool, because everything will shift. Now, my tool post is not locked in tight or with a pin. So if it does crash, it will move the tool out of the way and I won't damage the tool or the tool post in it. It's just a little bit of safety in that regard. Alright, it's deep enough to run a die now. Right, belts are slipping. Right, threads are successful. Now the belts are slipping because I've got my stock running through the back cover, so I can't get to the pulleys to pull it tight enough. So I had to resort to manually run it. Okay, the drill started to wander off, so I've got my 5mm end mill in here. Sorry, that's a 6 mil. Let me just change it to 5. I'm going to use a 5 to correct the hole to get it to cut center. Okay, this hole is stepped, so it's 6mm up to here, and then 4mm up to here. Now I've chipped my 4mm reamer. There was I don't know what was inside here. I think there was a heavy burr on the start of the, what's his name, and those bits got stuck in the. So what I've done is I've taken my 4mm end mill, one of my high-speed steel end mills that the tip was already damaged, and I had ran it through there to get that bits pulled out of the side. So yeah, that's it looks like it's a week of disaster for me. But anyway, let's carry on. I'm gonna part it off, and then this face this end here, and then this part will be done, and then I can change the chuck to my collar chuck. Okay, you would have seen me when I was parting off this part here that I've broken the tip of the grooving tool, and I had to turn it around and recut it. The reason for that is I was turning the lathe too slow, and I was trying to maintain the cut, and because of it being slow, it grabbed it and broke off the tip. I usually run it at 800 RPM, and what's his name? I was running it at 160, and for that carbide it's way too slow. I've set the lathe back to 870 and got it, what's his name? My collar chuck installed, so now I can do all the other features. The part is slipping, that's why it's not cutting. Okay, I've reinstalled it in a chuck with a 12mm collet. I was clamping on this surface here, but it was slipping. It was just too small for a collet. So with a 12mm collet, I'm chucking on the, or clamping on the threads. And now it's got a shoulder, so if it wants to pull or push the part in, it will push up against the collet and hold it in position. And this one is done. Okay, I've got a 7mm rod in here. Now I need to cut it down to 4mm on this section. Now because of the long stick cut, I'll only take 0.1mm on the radius to prevent it from bending. It will work, it's not too tight. Okay, now I need to move out the part a little bit more and then cut the portion that's going to be 6mm. That 6mm portion is going to pull up into this body. I've got a part turned around and faced. So now what I'm going to do is I'm going to cut it with a 12mm RCMT tool or a button insert. And that's going to give me that sloping taper that I need for it to seat into the indexing plate. Okay, I've set my compound at the angle because I want the handle to have a little bit of a taper here in front, just a bit of aesthetics. Okay, it's all cleaned up. Now the edges have cleaned up on the belt sander. I just wanted to remove the tape, the draft angle that was on the part, just to get it nice and flush. And I've used the perimeter that was already on it on the top. So I've just used that as a benchmark to get the runs right. And I tried to keep the natural bevel that was, or the fillet that was on here, that was in the casting. I tried to keep it as much as possible. Right, so now my next operation is to slot it and to drill in a M12 by 1.75 hole here. You saw me run the end mill 3 times through the pocket here. Now I've started off with a 12mm roughing end mill and cut the length, followed by a 13 and then a 14. So it's 0.5 millimeter each side. So that's to keep the end mill from running to the sides and to get the slot straight and equal on the sides. And I've done off camera, I've taken off the corners or deepened the corners here with 8mm end mill, because if you look at your, it's tighter now, because of this insert that I've got here on to provide me with two flats that has got a 22mm radius, and in order to clear the corners, to take out these corners here to give me the full range. So yeah, I've got a little bit too much play for my taste on the plunger, so I'll remake another one off camera. But for this build series, for the video, it should be good enough. So it works like a normal indexing head. You can run it, place it in position, and move your, what's his name. I haven't bolted down the plate yet. It's just for demonstration purposes. So yeah, I hope you enjoyed this build. Yeah, this was quite hairy. Now I haven't glued this joint yet, because I need to remake the plunger. Now, the reason why I said it was hairy, I had a couple of mishaps on making the whole assembly here. In the beginning, I had a short piece of rod which I wanted to hold in the chuck and do the machining from both ends, just to help me with the work holding. And when I was cutting the threads, it was just a disaster. This was my first attempt, and what I was doing is I was cutting a relief, a single point, cutting the relief, and then try to run a 12 by 1.75 mil die over it, and the die kept on binding, and I couldn't understand why. And then I scrapped this part, made a new one, which was this one, and it came out better, but the die still started binding, and I really couldn't understand what was the issue. And when I came to this one, the third one, all my threads were gone. And then I started to realize that there's a problem with my timing on between the TDI and the lead screw. Then I went back to the lead TDI because I usually pick number 1 and then just run with it, only to find out that the TDI does not cater for a 1.75 millimeter thread. Neither does it cater for a 0.7 millimeter thread. So you have to cut as if you would cut imperial threads. You have to keep the lead screw engaged. So I went ahead and I cut this one here, and the threads came out beautifully, and the die went over for the cleanup pass and clean up all the burrs. Everything just went peachy. And then when I placed it in like this on the chuck, and I tried to cut this piece, it grabbed, and as you can see, it bent it into oblivion. So I lined it up in a 4th attempt, and this time I just decided I'll make the 2 pieces separate using a long piece of stock, and that worked out well. Now the plunger for this I made it a plunger initially, the one that you saw in the video in the beginning, and I showed this one. No, my mistake. I made the one in the video. You saw me cut this one in the beginning, and when I did a test fit, I found out that the 6 millimeter section was too short, so I had to lengthen the part completely by about 7 millimeters. And then you saw me do this end with the RCMT tool, and then the threading in the back. Now with everything, all the disasters, bending the back end on this part, crashing the lathe a couple of times, bending those parts, I reasonably got my issues sorted out. So when I make the plunger, the core section, remake it, and I should get it right first time. I've also learned not to bring out or try to give a long stick out, because that just lands up in disaster. Now the reason why I've got a little bit of play is here where I've tried to cut threads and it went a little bit narrow. So I gave it a relief there, and that relief is causing this play here. So yeah, it's been quite an adventure for me. That's I have to admit that I spent 2 days on here because of all the errors, and I'm trying to troubleshoot as to what the problem was. But I got it sorted out, and I think it's reasonably, it came out reasonably well. And this amount of play, it doesn't transfer to your table itself, because you've got a 40 to 1 reduction, so nothing here. This amount of movement that you see here, that's a backlash on the rotary table itself. So yeah, I hope you enjoyed this adventure with me. It's now came to a close. Now it's for me to fix up a couple of things off camera, and then I'm ready for gear cutting. So enjoy. Till next time. Cheers.